one of them for attitude control. Basically, the output from the gyro goes into the computer, and the computer can tell what's happening with the roll rate of the spacecraft. Then we have a second gyroscope that is supposed to check on the results from the first one, and then the third one's off. It's a backup, basically. At some point, basically what happened is because of an error in the script, but the gyro that was controlling the spacecraft, we were supposed to be getting us data about the roll rate of the spacecraft, was actually turned off. When you turn off the gyro, instead of giving you the actual roll rate, what it gives you is a constant signal that you're rolling, the spacecraft is rolling. So what the spacecraft in turn did was, because it was detecting a roll, it fired the thrusters to try to roll it in the other direction. And of course, as far as the spacecraft could tell, it wasn't working, so it kept firing the thrusters, and kept firing the thrusters, and it just kept doing that until the spacecraft was spinning so much. I don't know if you, like a top. If you spin a top, if you spin like a very large object too fast, it'll change its axis of rotation suddenly. I forget what that's called.
Perturbation.
Huh?
A perturbation. Or
It rolls over to one of the other.
Yeah, basically it wants to rotate about its axis of least moment of inertia. So that axis of the spacecraft was actually not the direction that was ideal for us. So basically the solar rays turned away from the sun, and the spacecraft was spinning in that attitude for a very long time. There was no sun hitting the solar rays.
I guess
it's
it's
like a
like
little
this.
model.
That's a nice spin. This is this is a nice spin. This is a nice spin. That's a nice spin.
I should say, SOHO was designed not to spin at all.
Right.
It was also a very large spacecraft, so it actually was only spinning about 1.5 RPMs when it finally tipped over. It doesn't take much because it's a huge spacecraft. It was a lot of mass, but that was enough to make it tip away. And once it lost power, we couldn't do anything to it. Eventually, because of the way it was spinning, again, I wish I had something flat.
There's actually a really good article
okay.
online about
So,
that.
so normally, the front of the spacecraft, let's say the sun's over there, right? So the solar rays should be hitting the sun all the time. So when it first started spinning, it was fine, but we didn't know it was spinning either because our gyroscope was off. But eventually, because of the perturbations, it basically started spinning like this. So edge on to the sun. But as you go around in the orbit, even though it's edge on now, as you go further around, eventually, imagine the sun's now over here. Even though the spacecraft has not changed its attitude, the sun is now hitting the solar rays half the time. Of course, hitting the back of the solar rays is no good because we weren't smart enough to put